Welcome to my statistical research project titled Modeling March Madness Picks by Simon Peter Nyamoko-Agata. Research on the NCAA Bracket Challenge or March Madness has been done in academic as well as in corporate spaces. The vast majority of these projects have tried to create the perfect bracket by modeling the teams and matchups, and not a single project has yet predicted the perfect bracket due to the nearly infinite number of outcomes. Instead, my project models how the people who participate in the bracket challenge choose which team they believe will win. In order to tackle my research question, I first had to gather data. I gathered 4 different data sets. One I called pick distribution, another one RPI, KenPom, and tournament wins and appearances. Pick distribution gave team, seed, year, round, and most importantly, the percentage of participants who chose that team to win that game. RPI data is a quantity used to rank sports teams based upon a team's wins and losses and its strength of schedule. It's also called the ratings percentage index. Thus, the main use was to produce the ranking variable. The Ken Pomeroy set gave advanced statistics that are adjusted for schedule strength and tempo. It produced the adjusted tempo, adjusted defensive efficiency, and adjusted offensive efficiency variables. And finally, the tournament appearances set produced the tournament wins, which is the number of tournament games a team has won and the number of times they made the tournament. Since I wanted to use multiple linear regression in order to tackle my research question, I had to choose a response variable, and that was percent from the proportions given in pick distribution. I changed this percent to odds and later transformed it to log odds, and this is because there was not actually a linear relationship. Thus, that transformation to log odds would make that relationship now linear, allowing us to do a linear regression. Odds also gives us an easier data point and statistic to interpret, especially to someone who's not necessarily a statistician. Variable selection was a vital part of my research because it revealed which of the variables were statistically relevant. My raw data set was comprised of 10 variables, which are listed on the left side of this table of coefficients. For rounds 1 through 3, I included all 16 seeds, but for the rounds that are listed on the slide, 4, 5, and 6, I included select seeds. This was because the percentage of participants picking higher seeded teams to win in later rounds was nearly 0, and thus taking the natural log of 0 presented problems for the response variable. On this slide, at the top we have an example of a multiple linear regression model specifically for round 2. What's important here is since the intercept tells us a value when x is equal to 0, it is useless in this model since there is no 0-seeded or ranked team. The seed effect is captured by the seed and seed squared coefficients. Here we can see that the difference in log odds between 2 seeds that are 1 seed apart, like a 1 and a 2 seed, is negative 0.61748. Thus, the odds ratio for a 1 seed versus a 2 seed is 0.5393, which is a rather large gap in favor of 1 seeds. Record is not assessed in increments of 1 like everything else, but rather in fractional increments since it's recorded as a percentage. And finally, the tournament wins effect is another interesting piece of information because it showed how people weight the teams who have won tournament games in the past. Here we found that the odds ratio between having won 1 and 2 tournament games in the past 5 years is 1.05, which is a heavy favor in more games won over a 5 year period. There are a number of conclusions you can come to based on these results, but here are the main ones. So, first, seed and tournament wins are relevant factors for all rounds. That was a good thing, and but they were the only relevant factors across every round. Adjusted offensive efficiency and adjusted defensive efficiency are the least relevant factors, being that they show up once. Adjusted defensive efficiency shows up once in round two, but other than that, they never make an appearance, which was rather surprising. Tempo and adjusted offense efficiency did not factor in as much as we expected, and I expected them to be a heavier factor because higher paced and higher scoring teams would be chosen more often to win than lower pace, not as exciting teams. And rank is only significant in the early rounds. After you get into the later rounds, rank then becomes irrelevant. The largest and most important limitation that I had when doing my research were the number of years of pick distribution data available. There were only 3 years available online. Next time, I would, one, if I had a little bit more time, test this, comparing it to the actual March Madness picks this coming March Madness, for example. And I would also further investigate whether a 5 year range is the best range to look at for tournament wins and see if a larger or smaller range is more relevant.